Hi. Oh, thank you. Please have a seat.
Thank you.
Yeah, come to the front. Thank you. Hello, everybody. Thank you very much for joining us today for the AIAA Los Angeles section um, webinar. So today we have a very exciting topic. Everybody feel very interested about this. But before that, we want to say a few words about AIAA. As you know, AIAA is a professional organization, a leading nonprofit professional organization in aerospace. So if you're not yet a member, please take a look. If you are a member, please remember to renew. And for me, I'm with the Los Angeles section. So like Paul, his member here. So here we have a lot of aerospace industry, as you know, SpaceX, Boeing, Lockheed, recently Impulse Space, Millennium, which do a lot of satellite, and Jet Zero, Rocket Lab, Relativity Space, and you have USC, Cal State Long Beach, UCLA, and UNLV within our LA section. So it's a very vibrant community. It's the hub and the platform for folks in the industry. So we have more than 10,000, I'm sorry, 1,000 members just in our section, more than 30,000 nationally, internationally for AIAA. Then we also have more than 9,000 folks in our mailing list for receiving newsletter and events, and also more than 10,000 on social media. So even though a lot of people may not be able to join us today, but they already saw the messages and saw the speaker and the content, and also we are recording this video. It's going to be posted online. So please consider joining or renewing and participate. We have volunteering opportunity as well, including our speaker, Mr. Robinson today. Mr. Robinson and I, we met in the AIAA Ascent conference, Ascent Aviation conference. He and his company has a very exciting booth talking about the satellite communication using software IT tool for the next generation satellites. I invited him to give a talk. He has actually even more repertoire. We'll continue to work with him, like CFD and other like cybersecurity. But today, this topic is going to be very interesting. The LA section, we have been doing several space communication satellite events, including, but not limited to, say, the October. You can see online here, October 17. Is by our AIAA Fellow, National Academy of Engineering inductee, Dr. Jay Puchel, talking about NASA satellite, NOAA satellite, to monitor coast water imaging using hyperspectral. It's a satellite project. And also in May, we gave an award to Millennium Space here, doing the responsive space. So we actually have a couple of companies here, individual that work on responsive space, including Space Force. So just tell you that also on Thursday, September 19, we work with AIAA Microgravity Space Process Technical Committee, which I'm part of it. Dr. Jason Lee is going to talk about the Mars Analog project he did with NASA. And September 28, that we have X-15 by North America Aviation, which was produced here. It's a very exciting project. And so you can look at our website and webinar and look at, we also have mixers, happy hours, and retiree meetings. So it's a great opportunity. So I want to show you this. This is our national website, and you see the gentleman here, Mr. Clay Murray. He is going to become our new CEO starting October 1st. Our current CEO, Mr. Dan Dumbarger, is going to step down afterwards. So as you know, you probably don't know, Mr. Clay Murray actually previously is involved was with Vast Space. Vast Space is actually right here in Los Angeles and Long Beach. They have two locations. And Mr. Dan Dumbarger used to work in NASA. He worked on, he directed the vertical flight, horizontal moving rocket called DCXXA. It's very exciting. So AIAA has very good connection to commercial industry and to NASA and to education, research, and and many student professionals. So just give you some brief, and so hopefully if you are interested in ALW, please let us know. Let me know. So without further ado, let's welcome Mr. Asim Robinson. He has a great repertoire of experience, so I would let him to introduce himself because you already saw his bio, in the flyer. He has a lot more, but so I leave it to you, Asim, to work. So let's welcome Mr. Asim Robinson. Thank you.
Ken, thank you for having me. I really appreciate it. Let me actually share my screen so I can go through uh, something that I have prepared. Once you stop sharing, then I can share.
Yeah, I understand. I'm starting sharing now.
Sure.
Um, eh, Go ahead.
Sure, absolutely. So, just want to give a little into introduction. Let me actually start the slideshow, and let me see if you guys can see the slideshow.
Oh, please also say something about yourself. People want to know about you.
Oh, yes, I am a software engineer. I'm, uh, I have been in the industry for over 20 years, um, working with different companies such as um, AT&T, American Express, Markel, um, Pratt and Whitney, uh, and various other companies. So we started Surge Streams in 2018, um, and we have been, servicing multiple companies. And I do have something else about Surge Streams here in the slide, so I'll just continue. So
Okay.
basically, yeah.
No, no, I didn't want to interrupt you, but your slides is kind of in the preparation. Like for the speaker, then you have a side screen. Is it possible to switch to a main screen for folks online?
Sure. Let me do that. Let's see.
Yeah, because right now we see a side screen with notes. You know,
Oh, okay. I don't. Okay, let's see. What I can do is maybe stop right now and let's just go through it like this so there's no confusion. Is this better?
um, I guess that this we see PowerPoint. But if
Yes.
it's okay, I have no problem.
Right. I was trying to get us to the slideshow. Um, and if it's taking you to another screen, then
Yeah,
uh,
what we see here is on the left, that's the slide, but on the right, that's the next chart. But that's okay. If it's too much trouble, you can keep going.
sure. Let me switch back so that at least you guys can see the PowerPoint, so that I know that you're seeing the full screen. Okay. So, thank you guys. I came to talk about, satellite communication services and mission planning systems. And uh, we have been involved in developing systems for some undisclosed clients at the moment, and we'll continue to share ourselves story about ourselves about Surge Streams. We are a leading implementation partner, so, SearchStreams is the leading IT consulting and solutions company, and we provide a wide range of implementation services. Um, we specialize in IT infrastructure, digital transformation, delivering innovative solutions for mission critical operations across different sectors like space, finance, healthcare, and more. Um, yes, we do production support. We do all kinds of services when it comes to IT consulting. So for partnering with SurgeStreams, um, uh, some of our services are infrastructure design and deployment, systems integration for enhanced efficiency, data management and storage solutions, real-time data processing, and advanced analytics. We also do computer programming, um, and deployment development, Scrum teams, and just overall IT support for your organization. We're here today to talk about satellite communication services, and some of the things that we have been developing um, for the undisclosed clients. So let me start talking about that. So I'd like to, just give a brief intro to like some of the services that are needed to talk to the satellites and to the spacecrafts. Um, One, you have command services, and what command services are, they're just a sequence of commands. Um, and commands are used to command services are used to execute the commands on the via the ground station to satellites. You have like multiple ground stations, right? And those ground stations are able to connect to the satellites. And the command services basically execute those commands and communicate with the satellites. You have telemetry services, and those are basically the components of they have like the components of the spacecraft, like batteries, antennas, um, and telemetry services get the data from the satellite, um, and it gathers and transmit the data from the spacecraft to the ground control, which includes operational metrics for the spacecraft. We also have resource services, and those resources services can tell you like how many resources you need, like petrol, or like what distance you're moving, um, and like if you have a good amount of battery life, etc. Right? So resources help you prevent resource depletion, manage system longevity, and optimize overall mission
Excuse me, Asim, I think I found a way to do the full screen. So can you click the share the icon for the slideshow?
Yeah, this
Uh,
one.
yes.
Okay.
And can you click the three dot at the bottom? Three dot. Yeah, in the middle, there's a three dot below the
Yes. Yeah, I see it.
hide presenter view.
Oh, perfect. Thank you.
Okay, welcome.
All right. So I think I talked about the resource services, and the resource services are basically um, going to help you with the mission performance and the system longevity and optimization of all of the different resources, so that you won't run out of resources. basically it's going to capture all that. Orbit services are like a tracking service. It's basically like a GPS service for like Earth. So we have like a map, and GPS usually have longitude and latitude. Orbit service would also include altitude. Um, and basically, it would calculate the spacecraft's current and future positions based on tracking data and orbital mechanics. So we also have route service, and what route service is for is to communicate to the ground station, like our software communication to the station, and and that ground station communicates to the satellite. So you would have like APIs, right, that connect the platforms to the ground stations, and the route service like communicates with the ground stations and are responsible to push the data and receive the data. We also have activity services, and activity services are a main um, piece of the services that will basically give interoperability between all of the different other services because um, like for instance, if we have a specific opportunity, like to reach the satellite from the ground station, then an activity service could be started, and activities start at like a fixed timing. Say like if you wanted to do 1 p.m. to 3 p.m. On a particular activity. Let's just say, like one of the activities was to collect the battery percentage, right? So from 1 p.m. to 3 p.m., we would attach the command to the activity and deploy the activity. So once the activity is deployed, then it's fixed and it's there to, actually do its job. So the ground stations will collect the data according to the activity time and push the data to the satellite. And ground stations, like, well, let me just talk a little bit more about activity. So activities it's just for planning all the spacecraft, all the activities that the spacecraft needs in order to perform the required goals to achieve like what the goals of the actual spacecraft. And when activity services are communicating, right? So let me tell you a little bit about ground stations. So ground stations are different stations across the globe um, where it will collect the data according to the activity time and push the data to the satellite. So ground stations will uh, there are certain companies that own ground stations, and they will charge you according to how much data you're going to use. So when you rent the time from a ground station or you rent the data from the ground station, it's like one of those services, right? Then you can get different services that come with that, right? So like there's another thing called uplink. Let me switch. Okay. There's another thing called uplink, and what it is uplink means that it will push the data, okay? And downlink means that we are getting the data, okay? So in activity services, right? We can plan from that particular time that we have the activity plan to get, like, say we want to get the correct location, we want to get the percentage of uh, the battery, we want to get the temperature of of the spacecraft, right? We want to get the battery life. These are, different things that we want to actually, measure. Um, like we need the battery temperature, and all of these things are important in sustaining the spacecraft. So spacecrafts have like embedded systems. Spacecraft have like antennas to push the commands, and once they push the commands, it basically will dictate the behavior in the spacecraft. Spacecrafts need some time to execute the commands because activities have a start time and an end time, and spacecrafts will allow the execution of commands in sequence because let's just say the spacecrafts have small circuits and small batteries, right? So we have to utilize the resources in a good way so that we we don't destroy the spacecraft basically. So it's best that the activities don't overlap. Like when we're delivering the activities, because first of all, we have only a limited time um, that the spacecraft and the ground station is lined up, right? And that really dictates why we need to really plan, like when we do the activity services. So the basically this spacecraft and the ground station needs to line up and to communicate with the spacecraft. So it will allow us to get get the data. We also have like metric services as well and monitor services. And those monitor services will apply the rules. Like for example, like if we can have specific rules, to be created there. Like if let's just create one rule. If the battery life is 94% and the battery temperature is 98%, then we need to alert the space engineer, right? Because that means that the battery might get destroyed soon because it's too hot and we already have a good amount of battery life. So and the battery needs to stop charging. So so what we'll do is that monitor service will have those rules, and then because of that, when we alert the space engineer, then the space engineer will create a activity to close the solar panel and stop the charging of the battery. So other services we have are launch services, and launch services cover like the planning, preparation, execution of satellite launches, and ensures a successful deployment. So that means that, the planning, preparation, all of this is data enabled, right? So when we are, discovering data, then everybody likes, to have the data where they need it, when they need it, and that helps us to plan the launch services better. There's also ground segment services, which um, ensure efficient communication between the satellite and Earth by handling telemetry. tracking and commanding operations. Okay? So those ground segment service basically ensures when we're at the right time, we're at the right time at the right place. It will we will make sure that we are able to um, have efficient communication between the Earth and handle the telemetry. Okay. Also, payload management services ensure efficient operation of the satellite sensors, instruments, and cameras, enabling the data capture and transmission to ground stations. And this is really important because, we need to be connected to those satellite sensors, the instruments, the cameras, and the data capture needs to um, transmit to the ground station. Now, data processing and analytics is very important as well. The data processing, we, analytics are very, very important for, scientists and everybody else who wants to get the insights through the data. And if there's some issues, we want to be able to do anomaly detection, predictive and analytics, and machine learning, so that we can predict different things. We can predict any issues that we might have with some of the any of the services with the spacecraft, um, with the satellite, and those are very important. We also have like orbital debris management. And basically, orbital debris management focuses on identifying, tracking, and um, mitigating debris to prevent satellite collisions. So it's basically monitoring, but outside of the spacecraft. So that's when like things like computer vision and other uh, detection systems become very important. Um, we also have satellite end of life services, which ensure safe decommissioning via like controlled deorbiting or relocation to prevent space debris and collisions. So if like the debris management system, connects to the end of life services, we might send a signal to decommission and do some deorbiting, or relocation, um, to prevent any collisions or any issues. Uh, Let me just reiterate some of these concepts to you guys. So, command services are used to execute spacecraft commands via ground stations. These commands include operations such as adjusting satellite orientation, deploying solar panels, or executing maneuvers. The commands are sequenced and transmitted through secure APIs using SSL, TLS. SSL, by the way, is secure socket layer, to ensure that they are executed in the correct order. So we all know that, we need to be secure. So we need to use secure, protocols in order to communicate these command services, because we don't want them to get hacked. We don't want any issues, right? Okay, so I'm gonna go through this a little bit. This is uh, a little bit of an example of some REST service to transmit a command to a spacecraft. And this example right here is using Flask to create a REST API. And the API would accept the commands in a JSON format, which is basically just an object format. And that object format, consists of different values. Okay. So the API would accept those commands and sequence those commands according to the sequence that it's needed, and then send them to the spacecraft's embedded systems. So here we have a Python example, right? And we basically send the command via an API post method. And this is basically REST, uh, a REST operation. So we actually, like, when we get the response, like we use an HTTPS, which is basically secure secure HTTP, basically to execute the command and to return the status of the commands executed. So telemetry service gathers and transmits the operational data from the spacecraft to the ground control. This includes data related to temperature, pressure, power levels, and other metrics. The data is collected in binary format and must be converted to human readable formats for analysis. Here's another Python example that shows how we can convert binary telemetry data into recent format and store it in an Elasticsearch index for real-time analysis. So we want to import Elasticsearch, and basically Elasticsearch is somewhere where you can do search and actually search out the data that you need, and it's like can handle it can handle big data in some circumstances. So basically, we're connecting to Elasticsearch. We're decoding the telemetry data, and basically we're just parsing the binary data, and we return the values that we're getting from the telemetry data, from the binary data, and putting them to variables such as timestamp, temperature, power level, and we basically process and store the telemetry data, and we can store it any places. We can store it into databases or Elasticsearch as well. So the resource services, again, resource services focus on predicting resource consumption, such as fuel and power. We can use machine learning models and apply this to optimize resource management to prevent depletion and ensure long-term mission success. So here is like an example or how to train the system using machine learning. There's a scikit-learn is a good framework to use to for machine learning and for predicting different things like fuel consumption for upcoming missions. So here is example which we are loading the historical data into a resource data CSV file, and that CSV file will contain the data that we want to actually analyze. So that data, we are preparing the features and the target from that data, getting like the mission duration, orbital speed, payload weight, fuel consumption, right? and then where we would split the data into training and testing sets. So we have the different testing sets here. And then when we train the model, we basically fit that model into it, and we can actually predict the fuel consumption for future missions, like, and get those predictions from the model that we're passing. And we can, also, print the, predictions. We can store the predictions. We can add it to, different and, analysis, so that we can also, look at all of the data and make proper and correct decisions on how we're supposed to operate in the future.
Excuse me.
Okay.
Excuse me.
Yes.
Sorry, on the screen, it seems to be a green panel on the top. It says Zoom meetings is using the web camera. Is there any way to disable it? Did you see it on your screen? In the middle, it says Zoom.
Yeah. How
Okay.
do you? Yep.
Yeah, thank you, appreciate it.
No problem. Thank you for noticing. Yeah. So let me continue about orbital services. Orbit services involve calculating the spacecraft's position in orbit. It uses orbital mechanics, and the calculations ensure that the spacecraft remains on its intended path, and avoids collisions with other objects in space. So this example, will demonstrate how to use the apostrophe library to calculate the position of a satellite orbit and basically visualize its path. So we're going to be using Python again. So we're importing the apostrophe library, and we get the coordinates, basically Earth location from apostrophe. Apostrophe is another library, um, and basically we define the location of the observer, define like where the ground station is. So the Earth location, the latitude, the longitude, the height, all of that goes into it, and the time, right? So time, basically, we are just when we calculate the position of the satellite relative to the observer, then we will get the location, we'll get the time and the satellite position, would basically get those values and get the satellite position, and then we can print the satellite, um, altitude and the satellite position. So this is a great way to actually get the satellite position, where the satellite will be, or where the satellite is at that particular time, and then you can use this information so that you can plan when you're going activities when you're going to be communicating with the ground station. So route services handle the communication between ground stations and satellites. This involves managing the uplink and downlink data and ensuring secure and reliable transmission. So here's an example again of using Python with Raspberry Pi to create, to read real-time data from the sensors during rocket testing. This data is processed and stored for analysis. So basically, we have a temperature sensor, we have a pressure sensor, we have a we have, we are reading the sensor data, and then we return that sensor data, and basically we are getting that the temperature, the pressure, and basically printing those based on what we are reading with that Raspberry Pi, which is basically a hardware, like a software to control like the hardware that is basically in an embedded system. So again, activities, like I said, this is like the backbone of um, satellite services and spacecraft services. And activity services focuses on planning spacecraft operations and ensuring that activities are executed in the correct sequence and at the correct time. So this example shows how to use Celery, a distributed task queue, to schedule and manage spacecraft activities, ensuring that tasks, data collection, and system checks are performed at appropriate times. So basically, we have a Redis server, which Redis is basically just a small database cache. It's not a full database, but it's would be enabled to grab the data and fastly get the data which we need. And then we define a task for executing the spacecraft activity, and we would execute that activity. And we can schedule the activity afterwards, after we define the task. So after defining the task, then we execute the activity. And in this case, we would collect the telemetry data and execute it after 60 seconds. Launch services. So launch services encompass the planning, preparation, and execution of satellite launches. And this includes pre-launch simulations, which is very important because you like when you do simulations, and it enables you to predict and you can plan. Vehicle integration and mission-specific customizations to ensure the successful deployment of satellites into orbit. So here's like launch simulations, for example, are performed using trajectory analysis software that ensure the launch vehicle follows the planned trajectory and meets the mission parameters. And this involves accounting for various conditions such as weather, payload, weight, and the rocket's propulsion system. The ground station software would track satellites using telemetry data. And this example uses Python and a tracking algorithm to predict satellite position based on the input data that we have. So we are basically calculating the position, which is the latitude, longitude, altitude, and the time, and calculating the position using the data that is given. So ground segment services are essential for the effective communication and control of satellites in orbit. And ground stations handle telemetry, tracking, and commanding operations and ensuring that communication between the satellites and the Earth remains secure and efficient. So the ground station software is responsible for tracking the satellites in real time, receiving the telemetry data, and issuing commands. The integrating these systems with cloud platforms, or also that a good thing like for cloud platforms, and it would allow for efficient data storage and faster analysis of satellite data. So this particular example simulates scheduling of payload data collection using task queue, ensuring that payload data is routed efficiently back to the ground station. So again, we have the tasks that we will load into the broker, the Redis broker, and then when we collect that data, we are collecting payload data, and we print the data that we're collecting from the payload, and we return that data from the payload, and we could actually collect the payload data and apply that to schedule an amount of seconds that you want. So payload management services are crucial for managing the operation of satellite payloads, which include sensors, instruments, and cameras used for Earth observation, scientific research, and telecommunication. Proper management ensures that data is captured and transmitted ground stations efficiently. Payload scheduling systems ensure that sensors and instruments on the satellite operate without interference and that the data is routed back to the ground stations efficiently. These systems prevent data loss and ensure timely transmission. In the below technical example, the large-scale data processing with Apache Spark. This example would demonstrate how Apache Spark is used to process large volumes of satellite telemetry data in real time. So we're using PySpark to get the Spark configurations in Spark context. And we set the application name to telemetry processing, and also the Spark context, which basically we pass the configuration to the Spark context, and then we could use the Spark context to parallelize that data according to the data that we're given based on that telemetry data that we are processing. And when we process that data and we have the map, and we can apply scaling factors and we can use Spark as a great system to process large volumes and big data. Data processing and analytic services are responsible for transforming raw satellite data into actionable insights. This includes data cleaning, anomaly detection, and predictive analytics, often using machine learning algorithms to improve accuracy. So the big data platforms such as Apache Spark, like I said just before, can process the large volumes of data, and they also enable distributed data processing across clusters, allowing for faster and more efficient analysis. So in this particular example, we'll be processing satellite telemetry data and filter it based on velocity and perform a basic aggregation. So we are again initializing a Spark session and getting a lot of the simulated data and creating a data frame to hold that information and give us the satellite ID, timestamp, velocity, and altitude. And we're filtering those according to the velocity and according to, you know, the different aggregations. Orbital debris management. As more satellites are launched into space, we we have to be very careful about orbital debris. So orbital debris management becomes increasingly important. These services focus on identifying, tracking, and mitigating space debris to prevent collisions with active satellites. And this example is here is like basically machine learning algorithms. Um, we can use it to predict potential collisions with space debris, and those systems can automatically adjust satellite trajectories to avoid debris, ensuring the safety and longevity of the satellite. This technical example is using basic machine learning model, and this example would be able to predict uh, potential collisions and recommends trajectory adjustments. So basically, we'll be training the data, the velocity, the distance to the debris, um, and the labels where we would have 0 as no collision and 1 as collision. So this is, you know, the different features. That X is the feature, and we have the labels. And as we train the model using regression, then we can actually predict a potential collision based on the new data and get the collision risk. And that collision risk will, you know, we can actually print out the collision risk, whether it will give us a no collision or collision, as you know, that we might need to do some adjustments. So again, satellite end of life services are essential for safety and safely decommissioning satellites. And this includes controlled deorbiting or relocation to graveyard orbit. And that basically means that we want to prevent space debris and potential collisions with operational satellites. And this example shows an automated system that tracks satellites' health and triggers deorbiting procedures when necessary. So basically, we're monitoring the health of the status of the satellite and initiating a deorbiting procedure if critical. So we have the health status of the satellite. If the health status is critical, then we initiate deorbiting. Else, we don't do anything. We just print a message that says the satellite is operational. And if we are deorbiting, then we will print deorbiting initiated. And basically, the monitor the satellite health, the example input, if it's critical, then of course we would initiate the deorbiting. So let me just discuss a little bit about ingestion, which is downlink, and that receives the data using ground stations and stored security. So route services connect it to ground stations using, like, we can use different ways through API, UDP, TCP. The telemetry receives at the telemetry services and converts the binary data to plain human readable text. and then we store it into the back end with structured data. We refine the data and apply the rules for monitoring and any alert systems, and analytics shows the data. So the uplink is the opposite, which is pushing the commands, and we push the commands to the spacecraft. Spacecraft performs that um, those to achieve its required goals. So first, we prepare the activities with when the start and end times will be. Second, we'll prepare the command and attach to the activities which we need to execute to the spacecraft. We also lock the activities and confirmed, because like when we lock the activities, we actually are basically deploying that activity. And we prepare the route services with the commands and activities needed to be to be communicating with the ground stations. We collect confirmed data back and command execute success or failure from the ground. So we would also collect the status of the command. Let me just quickly talk a little bit about rocket testing services, because those are also important key services um, to, um, to have when we are actually testing rockets. So we have data acquisition, which is a collection of data from various sensors, which includes the temperature, pressure, vibrations, etc. The data logging and real-time processing, control systems, okay, which would manage the flight operations and telemetry, control of engine parameters and performance, real-time adjustments based on the feedback. And we also have safety systems, which are emergency shutdown mechanisms, redundant systems for reliability, and predefined safety protocols. Data acquisition during a rocket testing, data acquisition systems would collect data from sensors that monitor parameters such as temperature, pressure, and vibration. This data is processed in real time to ensure that all systems are functioning correctly and safely. Here's an example of collecting those real-time data from the sensors during rocket testing, and the data is processed and stored for analysis. Um, as you can see, we have a temperature sensor and a pressure sensor, and we are reading that sensor data and basically printing that sensor data, temperature and pressure data. Um, Some advanced services for rocket testing are simulation and modeling, simulation of physical conditions and rocket behavior. And these are very important, and some things that, I believe students should start looking into these things as well. Virtual testing environments for software and hardware integration, scenario modeling for various mission outcomes. We have data analysis, which is a real-time and post-test data analysis. Predictive modeling using machine learning. Communication systems like our real-time telemetry and data transmission. Secure communication channels for command and control. So the simulation and modeling services involve creating virtual environments to test how rockets will behave under various conditions. So these simulations will help the engineers to predict possible failure points and ensure that all systems are functioning correctly. And here's an example for real-time data sensors during rocket testing. We can have the temperature sensor, the pressure sensor, and basically, print those um, and, and using, Open Modelica, which is also a library. These are some different like Python libraries that we can try out. Just wanted to, quickly talk about the future insights in aerospace and space technology, and just talk a little bit about where it's going and how it's progressing in the future. So the future of aerospace technology is set to be revolutionized by several emerging trends that will significantly enhance satellite communication, rocket testing, and space exploration. We have a lot of advances in AI, quantum computing, and 5G technology, and many others. So artificial intelligence is playing a crucial role in the automation of spacecraft operations. And AI-powered systems can detect anomalies, perform predictive maintenance, and execute autonomous mission planning. This reduces the reliance on human operators and enhances mission efficiency. Quantum computing holds the potential to revolutionize satellite data processing by performing complex computations much faster than classical computers. This could lead to better encryption, faster data analysis, and real-time decision making for satellites and spacecraft. 5G technology is expected to integrate with satellite communication to provide enhanced global connectivity. And this will also lead to faster data transfer speeds and improved communication for IoT devices, autonomous vehicles, and space missions. So, conclusion, and thank you guys for having me. But just want to say, Surge Streams is at the forefront of innovation in satellite communications, rocket testing, leveraging state-of-the-art technologies to drive this future of space exploration. And by embracing AI, quantum computing, 5G technologies, and all the various services that are involved in space services and satellite services, our company is positioned to contribute to the next generation of aerospace advancements. Thank you. I'm going to leave space for any questions. I also have one of my engineers, Rohit Dabaria, right here in the meeting. If anybody wants to ask any questions.
Oh, yeah. But first of all, this is wonderful. Thank you. This is very complete and very exciting, presentation. So Rohit is sitting with you, or he needs to be moved to the panelist. Is he
okay, I guess you can move him to the panelist if you want.
So he's not physically in your office?
No, he's not physically with me at the moment.
Okay, okay. I saw his name, but I didn't actually realize.
Right.
Let me,
sure.
Hey, Rohit, just accept it, become a panelist. Yeah, I asked him to. Well, if he doesn't want to, show his face, he can just use the voice. But first of all, while waiting, so anybody online, do you want to ask question? If you, okay, so Rohit didn't want to be a panelist. So Rohit, your microphone is enabled. So if there any question, you can use your microphone to speak out. Can you
he's saying it's not allowing him to speak.
But his microphone is enabled. Let me try again.
Okay.
I think one is enable his microphone. It seems to be okay. The other is panelist, but he declined. So, but while he's it looks okay though. His microphone. I asked him to unmute. Let's see. Rohit, can you accept it and use your microphone?
I have Rohit. I just pulled him up. Yeah.
He has not allowed me.
Okay. Can you hear? actually, like, you guys can start asking Rohit the question. Can you hear Rohit's voice from my screen?
A little bit, not
Okay.
direct, but we can try. Okay, so folks online, if any question, you can. I urge you to click raise hand. If you click raise hand, we'll enable your microphone. Like Siva now he has a microphone, so he can ask questions verbally. I think that's more direct. If you type, then people have to read, so if you want to speak out, so anybody want to speak out? Um, Siva, do you have a question? You have the microphone. Or Paul, do you have any?
Well, let's see. Can you hear me?
Yes.
Mr. Gary Moore is actually our technical chair. Normally Saturday is busy, but he's actually supposed to lead this event if he like, but his Saturday morning is a little busy. I'm glad he joined. So Gary, go ahead.
Yeah, yeah. I'm out at the at a hangar near Riverside with the Wright Flyer aircraft, and it's a project from many years ago at the AIAA. But anyway, I just got access to the Wi-Fi out here halfway through this thing, and I've been interrupted plenty of times. So I missed most of the event, but the Python program that I saw was talking about simply distance to the target without mentioning. I didn't see number of orbits to approach or anything that suggested that this was all orbital mechanics. So, could you just quickly brief me on what orbital mechanics you use to go to approach your targets?
Rohit, are you able to hear?
No, it's not able to properly, hear voice.
I really didn't understand any of that.
Rohit, are you able to hear?
No, I'm not able to hear.
Are you in Zoom at all?
Yeah, but I'm using my phone to join the both calls. I receive the call and the WhatsApp Zoom is inactive.
Okay.
Okay, that was a very complex question asked by somebody who missed virtually all of the presentations. So, anyway, of course, Buzz Aldrin was known as Dr. Rendezvous,
Mm-hmm.
and I was just wondering, like, what part of that can we talk about here?
So basically, I think I was speaking about the route services and the communication between the ground stations and the satellites. I also spoke about the routing systems and orbital. So basically, once the orbital space debris management becomes, we basically we use latitude, longitude, and altitude, and we would identify the tracking and mitigation of not only the space, satellite, also the debris, and can use that to prevent the collisions and everything.
Well, I've got to preface this by saying, obviously, NORAD does its predictions of collisions and recording of orbital parameters.
Exactly.
And so obviously you've homed in on a specific target based on their information. And so mostly the debris is going in so many different directions that a debris collector virtually has to be specific to a particular field of debris.
Exactly.
It's way too expensive to change orbital planes. Not too bad to go in and out, but any amount of inclination change is very, very prohibitive. So, are we talking about like a cluster of these things to go out to specific debris fields, or what's the prospects of being able to use a system on more than one environment, more than one target?
Well, like for more than one target, basically, like we are just really using machine learning algorithms to predict the potential collisions with the space degrees based on the actual data that we have. So we'll be using features such as velocity, distance to the debris, and the like we'll be using like a regression algorithm to actually predict potential collisions and send it to the system.
How responsive do you consider yourself to be? Because you know the prediction of probability of collision, you know, is more and more difficult further in the future you start looking, and you have to be in essentially the proper inclination of the orbit and as close to the radius as you can before you start this thing, which basically is your launch parameters. And so so there's the question, basically. How
Right,
can
you
we?
have your launch parameters, and then you have your position, right? And you also have the position to the ground station. You have your activities, and your activities are you're going to actually be speaking to, you know, the like within that specific amount of time, you'll be um, talking to the ground station, right? So all of that data needs to be downloaded, downlinked to the ground station, right? And then that way you can use predictive analysis to um, determine your next moves, and you can create new activities and um, uh, and alerts to the systems.
So
So that
are you seeing a single system or a multitude of systems that you'll have at the ready for launch at some assigned time?
right. So basically, the platforms will enable like distributed data processing across clusters, allowing faster analysis.
Okay. Okay. I think I've dived deep enough into that, and that's my history. My history was I actually did work on the orbital maneuvering vehicle that TRW won a NASA contract on, and then we had sufficient uncertainties and budget cuts that terminated that program. But I'm glad to see that Tom Mueller is has been working a similar system that will go up, and I hope that we do manage to have a tour of that facility. I'd say the same thing about your organization. So,
Absolutely.
okay, so I'm off the air then, and I'll leave it for somebody else to follow up.
Oh, thank you. Very good question, Gary. So Paul, do you have any question?
That's a question. That was a good presentation, Asim. Thank you.
Thank you.
This is sort of a naive question, but you said that the telemetry data coming from the satellite is binary data, but why is it not coming out as a human data format to begin with?
Because it's faster. Like for example, like that's like the difference between using you know, byte code versus actual Java, right? So it has to get interpreted to the byte code or to the machine language to make the computer understand it more.
Okay, thank you.
Any question on folks online? Please click raise hand, so we'll enable your mic. While we're waiting for more question online, I do have a question, actually two. So Asim, number one, you talk about machine learning, AI doing a lot of prediction, those things. So are you using NPU, those kind of things? And those things are you talking about those kind of learning, prediction?
Yes.
On the ground control, or you're talking about autonomously on the spacecraft? You remember several libraries, right, in your code?
Yeah, those are some just different libraries that we can use. Like those are like basically we have like different you can use different programming languages. Like just Python is just easier to like explain. I mean it depends on actually like what systems that we are going to use, but in terms of Python, we can use those specific libraries just because they are made for, like prediction, they're made for modeling, they're made for, those kind of processing so that it will be a easier, like you can utilize some of those, systems without rewriting the code from scratch.
So those code, like you call library, those actions actually are taking place on a computer chips on ground, not on spacecraft, right?
Right, exactly, because the ground station will provide specific APIs to you, right?
Yeah.
So you can utilize those APIs and send through uplink all your various your signals to the spacecraft.
Yeah, basically just as a spacecraft to move, adjust, those kind of things, or sending the monitoring signal back. So you are actually not talking about putting a powerful chip on the satellite or spacecraft. They can do all those prediction themselves.
Right, absolutely.
Okay, yeah, because those computing stuff, they require certain computing power, but the computer on the space is more limited.
Exactly.
Of course, it would be good to have a robot in space that can fly around themselves, but yeah. But
we'll get to that later, a little bit later.
Yeah, actually, yeah, you're right. Exactly. Later, we're waiting for you. So at this point, or in the facility, are you thinking, using computer with NPUs, or you are already using it, NPU, for the AI?
Yeah, in the future, yeah, I'm contemplating, and yes, that's very susceptible to happen very soon.
Actually, this is what related to my next question, because you're talking about you're using Python because it's easier to explain the concept. But who decide which software, which package? And actually, my question is somebody want to work with your company, and then you list of all different service, services. You are talking about different number 1, 0, 1, 0, 2, 3, 3. Are those software decided by your the source? For example, say Boeing or Millennium Space, they contract you, so they determine that what software you should use, or you decide on your end.
Well, there's typically two ways that can happen. Typically, if we come in and we are, presented as thought leaders, right, then, and they want to hear from what is our experience and what do we want to actually do, like architecture of the system, then we would come, we will put together proposals of what kind of technology that we want to use that would be actually good, and then we go back with the company, and the company would we would just get feedback and talk to the architects and decide on the correct technology to use for the systems. Or if they have existing systems and they need help with the existing systems, then we're able to come in and work on the existing systems and create the services like that.
So actually, it could be any of the how many category? Like 11 or 12 category, right? When you present it, so it's not you have to do everything. You can do part of it.
Right, exactly. Exactly. It's all custom, so like part of it could be done, depending on the needs of the of the company. Right.
Then my next question related to this is so what some company, they must have their in-house people doing some kind of at this basic level. So what can you say a few words? What is the advantages, that working with you that can kind of complementary to the in-house people or do better than their in-house people?
Yeah, absolutely. So not only is SurgeStreams able to work, and scale up and scale down based on the teams that you need or the people that you need. We are able to help you plan, help you to with implementation. We can work with certain budgets, and we can actually like collaborate, and if you want us to be thought leaders, then we'll also present you with our data, like what our expectations and technologies we can provide, our experience using technologies and various sources of industries, which are susceptible to the best application, the performance and the application stability and scalability of the applications.
Very good. And yeah, of course, in this area we have so many companies, and they do rockets, satellites. It's kind of also, when if somebody asks us, what's the advantage? Then we can tell them, there's a senior companies that can do this, and it can provide architecture analysis or whatever level of the implementation or advisory, to help people work or those kind of things. Then you did mention something very interesting. You also mentioned about student. That's
Yes.
rocket simulation or rocket testing. Or let me explain to you. Actually, in here we have 4 major university branches: ALFA, Cal State Long Beach, USC, UCLA, and UNLV. I don't know about UNLV, but the other 3, they have their own CubeSat. Actually, in fact, our Cal State Long Beach student lab just got awarded this year, selected among the 10 universities that received the free NASA ride share by 2028. To launch, they call it Shark Set. They are building a CubeSat.
Right.
And actually their mentor, Dennis, is also our member.
Right.
He used to work with Northrop Grumman satellite operation. So USC too. And the USC USC, UCLA, and Cal they all have student rocket laboratory, especially the USC, the rocket propulsion laboratory. And
Yes.
Liquid is very well known, and they have they broke the student rocket launch altitude a couple of years ago. So how
That's
would
amazing. Yeah,
yeah
go ahead.
yeah I'm trying to say if something they do rocket testing simulation also UCLA too. We have Edward Fellow. She's leading a UCLA liquid propulsion laboratory. Cal State Long Beach too. They also have student rocket lab. So how do they benefit? For students, are you asking a lot of funding or money? Because for students, they might not have enough budget, to pay for you. So is it some kind of thing that what you can help them, but it's not like you are charging huge amount from companies. So because you must have been working with some student, you're helping them for. So
Yeah,
what
I mean, we have internships. We can offer internships to students depending on the projects that they're involved in. Or if students need some help, with some kind of analysis and everything, they could just feel free to reach out, and we'll be glad to take a look at the thesis, papers and everything that to get an understanding of what they want to learn and what they want to do, and we are very supportive of the student body.
So you won't charge a lot of money, right?
Oh, of course not. I mean, not especially not to a student. No way.
Yeah. But I'm saying, because I'm thinking, this way we can tell them and they can contact you. We can help make connection.
Yeah.
I think this is going to build, my understanding, I don't know if I can tell you too much, but I think they are building some kind of facility and they are building this. This CubeSat is going to be launched by NASA. So NASA obviously has been helping them, putting some resources to make sure the satellite will work and
Right.
survive, when they launch into space. So it's a very interesting project. They are getting support for building and launch and also ground control for it. And we actually have a professor, but I think she's coming here to work. She used to give a talk for her Cal State, university student CubeSat laboratory from ground control to building and communication. So you are right. Actually, this is very good. If you can, be integrated into the student, Airway student CubeSat or rocket testing project. And these folks, they are going to graduate and they'll be working in the industry. I think it's very good for you at both sides too.
Sure, absolutely. I'm very interested in that.
You're very interested. Okay, well, we'll definitely help on that end because I'm pretty sure they also want to learn, and you can help them to make sure that the satellite launched by NASA is going to work. You know, um, so
Absolutely.
very good. So all right, so we'll try to see if we can make a connection. This rocket testing, simulation, those kind of stuff. Especially USC. USC has. I'll tell their professor and see if it's the chair and see if it's something they could work with you.
Wonderful.
Yeah. So I don't see anybody click raise hand, but I do have a question because we have a kind of two or three webinar, especially during pandemic in 2022 about quantum computing in aerospace.
Yes.
Mentioned your company is quantum computing. I understand. The entanglement, those kinds of things could be good
Yes.
for encryption, those kinds of things. But do you actually? But these things, for example, the quantum computer. There are two ways. One, you can do remote and then connect to some expensive device like IBM or some company that use low temperature. They have the system. Another way is, which I think most of the aerospace companies have been doing, is it's not actually this quantum computer with low temperature, those kinds of things. they use kind of same, I think they use conventional computer, but use quantum computing algorithm. I think that's, but you still need kind of advanced computer, but it's not the real hardware quantum computer. So which way are you moving? Are you going to get your own low temperature quantum computer, or you are talking about implementing quantum computing algorithm?
Yeah, at the moment, I'll be using like, IBM system, something like that. But, until we have a real need for, purchasing our own quantum computer, then we won't be doing so.
Yeah, it's very expensive.
Yeah.
Even IBM, they only have a couple. There's some other company, but IBM, certainly in their dungeon or somewhere, has an expensive facility, and it's also very difficult to, they have to get physicists to maintain, a lot of wiring, those kind of things. But I do know, actually I can tell you because Gary mentioned TRW. One thing you people don't know, actually, one of the quantum computer company, I forgot the name, the founder was actually from TRW. So the quantum computer has tie with aerospace because TRW and the Hughes aircraft, they were actually founded the initial stage of the quantum computer. But then it kind of spin off, different kind of things. And I do know there's some aerospace company, you can, it's not secret, you can see it on the news. They already say they spent several $1 million on their quantum computing, quantum radar. It's not secret.
Right.
What exactly they use, that's top secret, but they tell everybody, they are moving toward that direction. So you are moving in the right way, so hopefully people can work with you.
Absolutely.
That's very good. So then you are talking about 5G, those kind of technology. So then you also know that we have SpaceX here, right next door. So they don't Starlink, those things. So so you're kind of referring to this space network, for this kind of thing, or because actually there's nobody else, there's very few other, unless you talk about military, Space Force, that's another different set. They have their own secret satellite system. But
Yes.
which direction you are kind of more interesting or more moving toward? You are talking kind of based on Starlink, this commercial system, for commercial satellite, or you actually thinking about, or you are already working with Space Force or kind of defense sector on this kind of secret satellite?
No, not working. I was when I was speaking about the 5G, I was mostly talking about like where it's going. I know that Starlink has the global coverage, like satellite communications, like with the 5G technology and backhaul for 5G networks. And it enables for high speed data transmission and uh, space IoT, operations, and so yes, but SpaceX role in the 5G ecosystem is very good because they have like a good collaboration with telecom providers. So SpaceX could partner with like 5G telecom companies that would deliver more robust and global 5G networks, and by leveraging that satellite technology, SpaceX could help telecom companies overcome the infrastructure challenges and uh, building like those 5G technologies, within the uh, terrestrial 5G technologies, because where it wasn't feasible before. So that would be very good help.
Yeah, I think the other speaking, I personally feel there's a great potential for this, not only in the industry, but also for, as I mentioned, I know several universities, they are building, everything that, involved in satellite, but of course for students. So they have ground control, hardware, software, sending signals, you know, of course, the satellite is not going to be, you know, like a real satellite, you know, CubeSat, you know, it's still a satellite, but they learn a lot of things,
Exactly.
and it's getting popular. You know, a professor, they are sitting in this lab, and student can learn everything hands-on, Raspberry Pi, you know, all kind of things, you know. So I
Yes.
see great potential in this, and I just mentioned, I hope you are here. You are East Coast, but I hope you are. Do you
Yeah,
come?
I'm in New York at the moment right now. Yes.
Yeah. So that's great. That's you know, keep on that because you know we do have kind of see the booming in the education. But AIAA, I'm speaking, I've been telling you, AIAA has been supporting the student CubeSat activity for more than 40 years. So people didn't realize AIAA student um, branches or conferences, they already have been doing the CubeSat communication hands-on for more than 40 years, and they even started with the small satellite conference in Utah,
Right.
and you can see a lot of AWA, um, you know, behind those student activity because that's the future. You know, students learn and they work in the industry and
Yes.
they continue to thrive and you know make um, the country you know any of the strong the industry is strong, prospers. So that's great, and this is a very good integration because some students they might have other discipline. You know, a lot of our students they are like know a lot of CFD, you know, or rocket fuel, rocket engine, aircraft, but they are not very familiar, you know, with this, you know, IO, those kind of things. But it's getting more and more important, as you said. Um, and we actually also have done several Raspberry Pi demo. You know, so we actually have a talk early this year. It's a satellite communication cybersecurity using Raspberry Pi. You know, so it's very, very interesting. We are trying to do some kind of hands-on, you know, learning, you know, for those kind of things. Um, so for the Raspberry Pi, I understand for rocket testing, that's fine. But when you mentioned you cited a couple times that in a satellite part of your talk, but um, for if you use Raspberry Pi for machine learning, isn't that a little bit limited? I don't assume you mean that you put the Raspberry Pi on satellite, which you can do, but it's not going to be long lasting. Um, so when you mention Raspberry Pi in your
So I
satellite,
mean, like Raspberry Pi as a ground station, basically. So yes, and that you could set up Raspberry Pi as a satellite ground station to communicate with the orbiting satellites, and by using radio hardware such as software defined radio
yes, I know.
and UHF VHF antennas, then you can receive signals from the low Earth orbit satellites, such as weather satellites and CubeSats, and even like the ISS.
Yeah, this is actually very interesting. Actually, personally, I did, but also some of the member, we use software-defined radio and get the image from NOAA satellite, and you know, again on computer you can receive it and something like that. Yeah, that would be great. You know, that I've been hoping, you know, we can do something as a small demo, you know, for students, you know, something like that. But for industry, that's, you know, probably need something more. You probably need to get them more interested in what exactly they want to do. Then we do
Exactly.
couple. You're right, like you did in Airway Ascent and Aviation. People saw you. They are very impressed. So with your presentation today and the recording and our blast of the flyer, and there are more than 10,000 people already know more about you. And actually, we also posted on the AIAA National Open Forum, you know, so that's good. Are you a member of AIAA, Rohit? Are you two AIAA members? Not yet.
I need to become a member. Right now, I'm not a member at the moment.
No problem. Just I mentioned to you, and because if you become member, you can also look at the national platform. You know, there's a kind
Absolutely.
of bulletin board, Of course, our LA section also have discussion board, and yeah, and let me tell you, okay, we are trying to do if we can get some hardware or something, we can do some very simple demo and get you. But the key thing is we are trying to make a connection between you and our branches,
Absolutely.
and the company too. Whenever so if you have some kind of like a flyer or capability list, a statement, I think we can let more people know about. We're not trying to advertise for you, because we are not. But this is a platform. If people ask about this speaker, they can say, hey, this is what you can do, and if you're interested, please communicate yourself. We are not trying to gain anything in between. But this is good because our members and the non-members can learn what's going on in the industry. And if somehow it turns out to be a mutual good collaboration between our members, non-members, and on the speaker side, that's highly welcome. Okay.
Yeah, that would be great, and I will be sharing like a capability statement with you.
Okay.
Can do that. Yeah, definitely. Sure.
I will definitely look for more presentation by you. So, by the way, anybody online, any further question? I don't see anybody raise hand, so I have to assume folks online. I don't see any in chat. Gary, I saw you leave. Sorry. Yeah, thank you. I know this is not a good time for you. Yeah, you see, he saw this as a very interesting program. I can honestly, this is very good, really good, because previous our talk, we have Professor talking about student satellite. We have the JPL talk about deep space network. We have responsive space, but I think your talk really kind of feature, how, say, a programmer or a system architect, like you are Scrum Master, actually, fit into, this, satellite industry. And even better, you even work on the, rocket testing, rocket simulation. That's really good. I really greatly appreciate your expertise and presentation today. So if nobody, any more questions?
I said, can you share the PowerPoint presentation later on?
Absolutely, I can share it. Yes.
Yeah.
I'll share it with Ken. Yep.
Okay, you can make it like a PDF, a smaller
Sure.
file, and then we'll post the recording online, so we'll send a link to everybody, to attendee. So thank you so much, Asim and Rohit. Sorry, people didn't ask about detail. I can ask. I wish I want to ask more programming questions, but really don't want to get into much detail for today. But in the next talk, and then maybe we can think about maybe Rohit can say something more about with you, Asim, like programming side of stuff. Yeah.
Absolutely.
Okay. Yeah, thank you so much, Asim. Wonderful presentation, and thank you everybody for joining us today. And look forward to see you next time in our Elevate Los Angeles section event. Thank you so much.
Thank you.
Thank you so much. Appreciate it. Okay, we'll start the recording now.